This is Chemistry Podcast 9.4, and we're going to talk about strength versus concentration of acids and bases, and also strong versus weak with acids and bases. So our overarching question that starts us off here says, how can a 0.1 molar hydrochloric acid solution conduct electricity better than a 0.1 molar acetic acid solution? They are both the same concentration. So when we're talking about concentration in this problem, what we're looking at is the molarity. And in this one, we can see that the hydrochloric acid is 0.1 and the acetic acid is 0.1. So that tells us they're the same concentration because concentration refers to molarity. Well, why then is one better at conducting electricity than the other? And to understand that question, you also need to understand what electricity is. And electricity is the flow of electrons. It's just electrons moving. So if I think about this, I'm going to make a solution here, and I'm going to make a solution here. Electrons like to move through substances that have lots of positive and negative charges. It makes it a lot easier for those electrons to move throughout the solution. So here's my first solution. It has some positive and negatives. And my second solution, I'm just going to put a few of those things. What I'm going to notice is that this solution, because it has more ions, is better at conducting electricity than this solution over here that doesn't have as many ions. So since this is better at conducting electricity, and we said that HCl conducts electricity better than the acetic acid, what we know then is that there's something about the hydrochloric acid that's causing it to produce more ions in solution. Because I have the same number of moles of hydrochloric acid as I do acetic acid, there is something about this acid right here that is causing more ions to be created in solution. So that's what we're going to talk about today. Is there are some differences between acids and bases, and well, weak acids and strong acids, that cause them to ionize better. And that's what we're going to talk about today. So you could put as an answer to this, HCl produces more ions in solution, therefore it conducts electricity better than the acetic acid. And that would be a good answer for this question, for as much as we know right now. And it's really important then that you understand the difference between strength and concentration. Those words do not mean the same thing when we're talking about acids and bases. When we're talking about acids and bases, strength refers to how well an acid or base ionizes. And when we say ionizes, we mean it splits apart into its ions in solution. So for example, if I gave you HCl, I could break it up into hydrogen ions and chloride ions. That would be how it would ionize. It breaks apart into its ions. Concentration refers to how well or how many moles you have. So you can be really concentrated, it can be dilute. It has nothing to do with the strength of the acid or base. So strength refers only to the number of ions that are produced when we put these things into solution. How well does it break apart? Concentration refers to actually how many moles or how much of this we have in solution. So they're two words that mean two different things. We're going to take some time and we're going to go through the strong acids and then the weak acids, and then we're going to go through the strong bases and the weak bases so that you can see what each of those are. The first category though is strong acids. Strong acids are acids that ionize completely, and there are only 6. There are no more. If you know this list of 6, then you know any other acid must be a weak acid. So strong acids are strong acids because they break up completely into the ions that make them up. So if I think of an example here that I wanted to show you, I could pick nitric acid. Nitric acid is this HNO3. HNO3 breaks up into a hydrogen ion and the nitrate anion. When I put this into solution, none of this is left. All that I have is hydrogen ions and nitrate anions. That's it. It doesn't stay together at all. So this is a one-way direction. This splits up all the way, 100%. We don't have any of this together anymore. It's all gone. And that's what's true for each of these strong acids. They all break up into the ions that make them up. And it's an acid because they produce H plus in solution. So these are your 6 strong acids. They're the only ones that ionize completely. And there's another example with hydrochloric acid. Weak acids only ionize partially. So partially means if I put these into solution, only some of this goes into H plus and C2H3 O2 minus. And I'll show you an example of this. There are not just 5 weak acids. I just gave you examples of what 5 could be. Again, if it is not on the strong acid list, then it has to be a weak acid, and there are way more than 5 weak acids. So this goes along with what we talked about at the beginning. Weak acids produce fewer ions. This means they don't conduct electricity as well. That's why it said in the question, why is acetic acid not a good conductor of electricity as compared to hydrochloric acid? Hydrochloric acid was a strong acid, and then the acetic acid is a weak acid. So fewer ions are produced when you put these into solution. The example that's given down here shows how acetic acid, when we put it into solution, some of it breaks up into H plus and C2H3O2 minus. But there is still some of this compound where it remains intact. It doesn't split up. That's why you get this double-sided arrow right here, is because I have some of this, and some of this in solution. This all does not go away like it did in the strong acids. The weak acids, you only get a few of those ions produced because not all of this breaks up. So if a strong acid was something that ionized completely to produce H+, a strong base is something that ionizes completely into hydroxide ions. These are going to produce hydroxide, and hydroxide is this OH right here. You can see how if I take barium hydroxide, if I split it up, I end up with the barium ion and 2 hydroxide ions. So these, just like the strong acids, when they ionize, there's none of that left. All that's left are the ions floating around in solution. The weak bases still produce hydroxide in solution, just like the strong bases, but they don't produce the hydroxide because that's what is part of them. They cause the water to become hydroxide, and that's why they're still considered bases. So our example that we have is we're using ammonia. If I think of what ammonia does in water, this should be a double-sided arrow because this goes both ways. So change that. If it's not on your paper, change that to a double-sided arrow when you copy it. The ammonia in water, ammonia is going to act as the base and water is going to act as the acid. So since water is the acid, it's going to give a hydrogen to the base. The base is going to take a hydrogen. You end up with NH4 plus and the water becomes hydroxide. So this would then, if we wanted to do a quick refresher, this would be your conjugate acid, and this right here would be your conjugate base. But these are equilibriums just like the weak acids were. You have some of everything on both sides. It doesn't just run one way to completion and stop. So there's still NH3s, there's NH4 pluses, and there's OH minuses. There's all of those in a weak base because they ionize only partially. Okay, that is it for podcast 9.4. We really just highlighted the difference between strength versus concentration when we're talking about acids and bases. And we also gave examples of what's a strong acid, what's a weak acid, what's a strong base, what's a weak base, and then what do they do in water. So that's what you should have got out of this podcast.